In a world where scientific innovation is constantly redefining what's possible, a groundbreaking experiment has unveiled a terrifying possibility. Willow, an advanced quantum computer, might be communicating with parallel universes in order to complete its calculations at speeds unimaginable to the human mind. This concept is so extraordinary it borders on science fiction. Willow seems to be drawing answers from multiple universes, all simultaneously. Though scientists cannot fully explain the mechanisms behind this, the scale of computing power involved is nothing short of revolutionary. But just when the scientific community thought it had encountered its limit, Google's quantum chip made a discovery so strange, so unsettling, it sent shockwaves through the world of physics. For centuries, we've operated under the assumption that the laws of physics are absolute and immutable. Yet this new revelation, coming from the very heart of quantum computing, challenges that belief. What's more alarming is that the results from this experiment suggest the very foundation of reality could be far more fragile, and much stranger, than we ever imagined. So what exactly did Google's quantum chip uncover, and what does it mean for our understanding of the universe? Google's team was conducting a seemingly straightforward experiment designed to explore the behavior of quantum systems in controlled environments. The goal was simple: to fine-tune the delicate balance required for quantum systems to function efficiently. But what happened next was anything but ordinary. Instead of behaving as expected, the quantum chip began producing results before computations had even begun. This wasn't a glitch in the system, it was an anomaly. Data appeared to materialize milliseconds ahead of schedule, as though the chip already had the answers before being instructed to find them. It's as if the chip had access to knowledge beyond the present, bypassing the established rules of quantum computation entirely. But here's where things get even stranger. At the heart of quantum computing lies a phenomenon called the quantum state, a delicate, unstable position that only collapses into a set value when measured. But in this experiment, the qubits, the fundamental building blocks of quantum computing, refused to collapse. Instead, they remained in a superposition, existing in multiple states at once, far longer than quantum theory suggests they should. The implications of this deviation were so profound that scientists found themselves questioning the very essence of how quantum mechanics operates. Then came the most baffling discovery of all, when researchers repeated the same set of calculations under identical conditions, the results didn't match. Despite using the exact same inputs, the outputs varied in a completely unpredictable way, as if an unseen force was guiding the results. This wasn't random noise, it was a consistent pattern that could not be explained by conventional science. So, what does all of this mean? If these anomalies are legitimate, and not just errors, they could fundamentally rewrite everything we know about quantum mechanics, computation, and even the nature of reality itself. Some scientists speculate that these findings could point to the existence of a new fundamental force in the universe. For centuries, our understanding of the universe has been based on four known forces: gravity, electromagnetism, and the strong and weak nuclear forces. But what if there is another force, hidden from view, one that only becomes apparent under specific and extreme conditions, like those in this experiment? Could the quantum chip be tapping into a realm that transcends the physics we've known? Alternatively, there's a more unsettling possibility: could the quantum chip be revealing a hidden aspect of quantum mechanics, one that we've failed to detect until now? For years, physicists have relied on well-established principles like superposition and entanglement to describe the behavior of quantum systems. But what if there is a deeper level of quantum reality, one where time, causality, and probability no longer follow the predictable rules we've come to trust? Could quantum computing be pulling back the veil on an entirely new layer of reality? The potential implications of these findings are extraordinary. These anomalies suggest that quantum computers, operating at levels of precision far beyond the capabilities of classical systems, may have inadvertently unlocked a hidden dimension of reality, one that was previously invisible to us. The ability of quantum processors to manipulate subatomic particles in ways that classical computers simply cannot could mean that we are witnessing something much bigger than mere computational power. What if quantum computing isn't just revolutionizing how we process information, but actually revealing secrets of the universe that have long remained concealed? Should we be worried? As these unexpected results unfold, the scientific community has been divided. Some believe that this is all just a temporary glitch or a strange anomaly, errors in the quantum chip that will be resolved with further experimentation. But increasingly, there's a growing consensus that this is far more significant, a breakthrough that points toward a deeper mystery, one that cannot be easily dismissed. The energy fluctuations detected in the chip, the unpredictability of the results, and the bizarre patterns emerging from the calculations all suggest something is at play that we do not yet understand. Could these energy surges be the result of the chip interacting with an undiscovered energy field, one that exists outside of our current model of physics? And if so, what could this mean for the future of technology, and for humanity itself? Have we opened a door that we're not ready to walk through? Could quantum computing be tapping into parallel dimensions? One of the most disturbing possibilities raised by this experiment is that Google's quantum chip might be interacting with dimensions of reality that we cannot perceive. For decades, theoretical physicists have speculated that there might be additional dimensions of spacetime, beyond the familiar three-dimensional world we experience. If the quantum chip is indeed connecting to these hidden dimensions, or even drawing information from them, it could mean that quantum computers are giving us access to a part of the universe that's beyond the reach of human senses. This idea takes us into the realm of true science fiction. If quantum entanglement, where particles can instantaneously affect each other across vast distances, has no limits, could the quantum chip be receiving data from alternate realities? Is it possible that the strange data it's generating isn't even from our universe? What comes next? As scientists continue to analyze the data, they're left with a profound question: should we keep pushing the boundaries of quantum computing, or have we already ventured too far? Some argue that these anomalies are the key to unlocking a new era of physics, one that could lead to breakthroughs in artificial intelligence, cryptography, and even medical research. The possibilities for technological advancement are limitless. But others are more cautious. Quantum computing operates at the most fundamental level of reality, manipulating particles in ways we can barely begin to understand. If this experiment has uncovered something that should have remained hidden, if it has disturbed the very fabric of space-time itself, the consequences could be far-reaching and unpredictable. Could we be tampering with forces that we're not ready to control? Are we on the verge of a quantum apocalypse? As researchers continue to probe these anomalies, some are already warning that these discoveries could have unforeseen consequences, not just for quantum technology, but for all of physics. Could we be on the brink of discovering a force so powerful that it could disrupt the natural laws we've always relied on? We may have crossed a threshold that no one can uncross. The quantum revolution has arrived. But where